All right, problem one from the review talked about margin of error and confidence intervals. So for this, we have a Gallup poll in 2014 that randomly selected 1,560 Canadians and asked them to rate the largest city in Canada in terms of safety. Toronto had the most favorable responses, with 81% of the Canadians polled rating it as a very safe city. Identify the following for the Gallup poll given above. So, letter A, it asks what's the population for this poll. So the population, remember, is the larger whole. So in this case, the larger whole that we're trying to gather information about would be all Canadians. The sample is the small piece that we study, like who it is that we're interviewing, or we're gathering data about, or we're doing an experiment on. So in this case, it is the 1,560 Canadians. So we're asking those individuals, those Canadians, how they feel about the safety of, the cities in Canada, and we're generalizing it to all Canadians. So we want to know first, is this percent an 81%? So it said Toronto had the most favorable responses, with 81% of the Canadians polled rating as a very safe city. So 81%, we're trying to figure out if that is a statistic or parameter. So a statistic, let me write some stuff up here. Describes a sample. A parameter describes a population. So in our case, the 81% is describing the sample. It's describing that 1,560 Canadians. So 81% is a statistic because it is describing a sample. For part D, we want to estimate how many of the 1,506 Canadians polled rated Toronto as a very safe city. So we know that it's 81% of 1,560. So to calculate that, we turn our 81 into a decimal. So we move our decimal 2 to the left, or divide 81 by 100. So we have 0.81. Multiply that by 1,560, and we get 1,264, because I rounded up. So that means there are 1,264 Canadians who believe that Toronto is a very safe city. Of the ones that they asked 1,560. Of them, 1,264 said it was safe. We want to estimate the margin of error. So remember, margin of error is 1 over the square root of n, where n is the sample size. So in our case, n is going to be 1,560. So we're going to do 1 over the square root of 1,560. And if you type that all on your calculator all at once, so 1 divided by, you hit second x squared on the calculator to give you the square root sign. So it gives us 0.0, we'll do 3 decimals, 0.025. That's the decimal. If you make that a percent, move our decimal 2 to the right, this is 2.5%. Now, I put it as a percent because we're going to use that to find the 95% confidence interval for this poll. So the confidence interval, we take our 81% and we're going to minus 2.5%. So that gives us 78.5%. Then we take our 81% and we add 2.5%, which gives us 83.5%. So our confidence interval goes from the lower end, so 78.5%, up to 83.5%. That is our confidence interval. And then our last step, we want to make a confidence statement about the poll in the context. So we're talking about 95%. So we are going to say, our statement always starts with, we are 95% confident that. Now, later in the year, we're going to change that 95 to different numbers. But for right now, we're going to start with 95. So we are 95% confident that. So now look at our problem. Let's say we're going to add the true proportion. So if you started with 95%, we are 95% confident that the true proportion of, start that, that's your first sentence. So of, now bring it in terms of the content, Canadians who feel Toronto is safe is between 78.5% and 83.5%. So you state your first statement, we are 95% confident that the true proportion of, then you bring it in terms of the problem, Canadians who feel Toronto is safe. So that was the whole point of the problem, right? Is Canadians who feel Toronto is safe. Then you bring in your confidence interval. So is between 78.5% to 83.5%. So your last statement can be, your last little like piece of your sentence is your confidence interval. So you have, we are 95% confident that the true proportion of, bring it in terms of the problem, make the interval the confidence interval.